Welcome to BioBonanza. Today we are diving into scientific method. But first, what is scientific method? Scientific method is a method used to solve problems created by Robert Boyle, a scientist born in Ireland who's credited with many other discoveries. The scientific method consists of 5 steps. These steps are observation, questioning and forming a hypothesis, which may also include making a prediction, experimentation, recording the data, and finally coming to a conclusion. We'll now dive into these 5 steps in more detail. Step 1. Observation. An observation is made just by looking at something. This thing can either be quantitative, related to numbers, or qualitative, which means it's appearance-based. You can remember these by thinking of quantities for quantitative and qualities for qualitative. Take a look at this short animation. What could a possible observation be? There are many possible observations that could have been made, but one that sticks out to me is how much the sprout grew when it was watered. Remember this observation for the next steps in the scientific method. Step 2. Asking questions and coming up with a hypothesis. When you're questioning something, you want to think about why it happened, but you also have to think about one important thing. This thing, or should I say things, are variables. These are factors or conditions that played a role in your observation that you made. The 2 types of variables are independent variables and dependent variables. Independent variables are the possible causes for something, and is usually a single factor. Dependent variables are the possible effects that were caused by a change in the independent variable. Once you have these things considered, you can think of hypothesis. A hypothesis proposes a possible relationship between the independent and dependent variables, and it can be thought of as an if-then statement. For example, from the previous animation, a hypothesis could be if the amount of water a plant receives is related to how much a plant will grow, then changes made to the amount of water a plant receives will result in a difference in how much the plant grows. A prediction can also be made, and it is similar to a hypothesis. A prediction shows a cause and effect relationship, and it can be thought of as if this is done, then that will happen. With this referring to the changing the independent variable, and that is how the dependent variable responds. Step 3. Testing. Next, an experiment will take place, where a change will be made to the suspected independent variable to see how the dependent variable responds. The group that has these changes applied is called the experimental group. In an experiment, there are also some variables that will stay the same all throughout the experiment. These variables are known as controlled variables. Controlled variables are different from the controlled group though. The controlled group is the group where nothing is done to them and they experience normal conditions. Tying this back to the animation, you could change the amount of water a plant gets and see how it responds over the course of 7 days. In this instance, let's say that 15 milliliters of water per day is the normal amount of water for the sprout. Any sprout that gets this amount of water would be part of the control group. Next, you could have as many groups where the amount of water is changed. But let's say 10 milliliters of water a day for one group and 20 milliliters of water for the other. These are the experimental groups. Step 4. Record data. After the experiment has finished, the data from it can be taken and recorded in a table. This data can also be used to create a graph to show the relationship between the 2 variables. Here are 2 made-up examples of how a graph or table could look like. These 2 examples are related to how a certain amount of water affects plant growth. When creating a graph, you should always remember to include these things: a title that relates the independent and dependent variables, an X and Y axis line, axes numbered in the same pattern, units on each axis along with a title, and a key or legend if that's needed. To remember which variable goes where when graphing, an acronym can be used. This acronym is DRYMIX. The D stands for dependent variable, R stands for responding variable, which is the same thing, and Y stands for the Y-axis, which is where this variable will go. M stands for the manipulated variable, which is the same as I, the independent variable, and X stands for the X-axis, which is where this variable will go on a graph. Step 5. Coming to a conclusion. When you come to a conclusion, you want to look at it and how it connects to your hypothesis and or prediction, whether it supports or refutes it. In a conclusion, you want to always provide data from your experiment to support your findings. That's it for Scientific Method on BioBonanza. Thanks for making it to the end of the video. Like and subscribe for more, and I also take suggestions for other topics you guys might want me to cover, so leave those in the comments if you have any.